Hello everyone, welcome to another session. Today we are going to look at Excel and we are working with Solver. We use Solver to help us solve complex problems, such as when you want to get either a minimum value or a maximum value or a specific value when you have many constraints, so you have many variables that you are working with. For example, you may want to know how many people will work in a certain shift, yet you are limited by resources, or just like in today's exercise, we want to know how to ship different things to different places, yet we are limited by the cost factor and also by the number of items that need to be shipped out. So let's go straight away to exercise 5. It's in the handout, Excel practice 5, and we are working with that company called Yuga Farm. So let's go ahead and enter that data. To save time, I have already gone ahead to enter the input data into my worksheet. So let me go ahead and click there. I saved the file as Yuga Farm. And when I open up, you will see that I have already put my data into the Excel spreadsheet. Now, for those of you who do not have Solver, let me just show you where my Solver is. I click on Data, the Data tab, and on the extreme right-hand corner, I have a section where Solver has been loaded in. If you do not have Solver, click on the link that is below this video. There's another video where I showed you where you go to add Solver into your worksheet. It's already inside, don't worry, it's part of the package of Excel, but you have to add it in. It's an add-in that needs to be inserted if you want to use it. Okay, that being said, if you look at my screen, I've gone ahead to put in the data. And the data we are working with is such. We are given the transport costs for shipping the cases to different places. Here we have Kampala, Entebbe, and Luwero. These are the 3 places that are producing cases. And we have 4 places, Mbale, Masindi, Gulu, and Masaka. These are the places to which the cases are being shipped to. But the costs for shipping are different. Like, for example, if you're shipping from Kampala to Mbale, the cost is 35,000. If you're shipping from Luwero to Gulu, the cost is 20,000. So we are being affected by the different costs of shipping and also the availability. Next here below, we have the demand. Mbale demands for 1,100 cases, Masindi 400, Gulu 750, and also Masaka 750. So if the company is supposed to make profits, it should make sure it doesn't send out too much to each of these different places, because they will not be able to sell more than the demand for that specific district. Then here below we have the supplies that are available from the different plants. Kampala can only ship out 1,200, Entebbe can only ship out 1,000, and Luwero can only ship out 800. So whatever we do, we want to make sure that everything we ship out is sold, but we need to make sure that we ship out to the right places. So that's a challenge we have. We have several situations or several constraints. We can't ship out more than is being demanded, and we have to make sure that we ship out everything so that we do not make losses. And depending on where we ship out, there is a cost implication. So that's our input data. So let's go ahead and put in what we expect to come out. Remember, the question asks us to make an optimal distribution that results in the minimum cost. So we want to make the most profit, sell the most, but with the least cost. So let's go ahead and enter that data. Okay, I'm going to call this a distribution schedule, and I'm going to make this bold. So to save myself time, I'm going to copy the cities and the districts. I've just pressed Control C, and I click right below here and I press Control V. So I've pasted, and I'm going to get rid of what is in here. So this is going to be our distribution schedule. And we're going to make an assumption. Let us assume that we are going to send 2 crates to each district from Kampala. And we are going to do the same for Entebbe, and we are also going to do the same for Masaka. Remember, this is an assumption. This is not the optimum. Solver is going to help us get the optimum, but we are just going to put a figure so that we get a gist of exactly what is going on. So here on the side, we are going to put the total from the plant. Total from each plant. Okay, I'll just increase the space here. So this is the total from each plant. So remember, this is an assumption. If we are sending out 2 crates or 2 cases from Kampala to Mbale, also to Masindi, also to Gulu and Masaka, the total that we are going to get from Kampala is going to be the sum of all these. So let me go ahead and put the sum. This is equal to sum, and I'm going to select all the 4 spaces, and I close my bracket and enter. So it means 8 crates are going to be sent out from Kampala, and I'm going to use the fill handle to do the same for Luero and Entebbe, meaning with this assumption, 8 crates are being, or 8 cases are being sent out from each of these plants to the different places. But remember, we have a constraint. The cases we are sending out from Kampala should, if Solver is going to help us, the total over here should not exceed what we send out from Kampala, but it should be exact. We want to make sure we maximize, and it's in maximizing that we shall optimize our distribution, okay? So we shall put in a constraint where we say what is sent from Kampala should be equal to 1,200, and the same for all the rest. Okay, so that is one. And then another area we are looking at is the total sent out, okay? We call it total to district. Okay, so here below, we are going to calculate if Kampala sent out 2 cases and Entebbe the same and Luero, the total we are sending from Mbale is going to be equal to the sum, and we open our bracket, of what has been sent to Mbale from all these different places, and we enter that too. And you notice that it shows up as 6, meaning that 6 crates are sent to Mbale, and I'm going to use the fill handle to drag this across, which shows that 6 crates are being sent from all these places to the different, from the different locations. But remember, whatever is sent to Mbale cannot exceed the demand from Mbale. Whatever is sent to Gulu cannot exceed the demand from Gulu, and so forth. Let me just put this in a border so that we clearly know what we are dealing with. I'm going to center, and I'm going to place a border. It doesn't affect, but it's just to make sure we can see our work clearly. Okay, so there are our different spaces. Just reduce this a bit. so that our work looks neat. Okay, so that's fine. And so we are set to go. Now this, remember what we said, this is the distribution schedule. What is happening inside here is a distribution schedule. I'm just going to highlight it so that you can notice what I'm putting in. I hope you'll be able to see my highlight. Let's use that color there. So these are the cells that we made an assumption for. The rest are formulas that give the total. So I'm wondering where to put this item here. Let me just put it here at the bottom. So our optimal or our distribution costs, let me type that, distribution costs. Okay, so the distribution costs are going to be as such. Let me put the distribution cost here. The distribution cost is going to be the number of cases that go out, like let's say from Kampala to Mbale. If 2 cases went from Kampala to Mbale, we have to multiply those 2 cases by the cost of transporting from Kampala to Mbale. So that is going to be 70,000. From Kampala to Masindi is going to be 2 times the 30,000, which is 60,000. So we have to add all these costs, and the function we are going to use is sum product. Sum product helps us to sum up all the products of the different costs we have. So let me go ahead and click in the cell where I want my distribution cost to go, and I'm going to start with the equal sign, and I type in sum product. Let me use caps so that you can clearly see. This is sum product, and I open the bracket, and you will notice that the formula shows that we have arrays. Remember what we said, an array is a range of data in the form of a table or in columns and rows. So once you highlight that array, you have to make sure the same number of items are highlighted in the next array. So let me go ahead and highlight the costs first. So we've selected all the costs for the individual spaces. And how do you know that you have highlighted? You will see a dotted line going around the range that you have selected. And we follow this with a comma. Notice that I'm down here, I press the comma. Once you press a comma, it gives you the option of selecting the second array. You need to make sure that the second array is also equivalent in number to the first array that you selected and the ones that follow. So I've selected right now our assumption of the two cases from each of the different plants to the different districts. And I'm going to close the bracket. There we go, and the formula gets away, and we are going to enter this. So this is our total cost right here. Let me just make this bold and large enough because this is our goal. Remember what we were told. We were told that we have to make this the minimum distribution cost. Let me just change this to total. This is a total distribution costs. Okay, so this is what our goal is. We expect to put this at a minimum. So we are done setting up. Solver is going to help us calculate the minimum cost, but we have to put in the constraints, and we are assuming, remember, these are the assumptions we put in. Solver is going to help us make the final outcome or the final distribution schedule based on the constraints that we shall put in. So let's begin with this. We go to data. I'm going to click. It's always better to click somewhere, to click in the goal. I prefer to click in my goal. We go to data, and we are going to click on solver. It's as though I have selected two sheets. Let me see what's going on. Okay, something is not right, but that's okay. We are going to check it out. So we are supposed to set our objective. Now, what is the objective? You want to make sure that you choose, do you want to maximize, do you want to minimize, or do you want to get an exact value? In this case here, we've been told to get the minimum cost, which means we are going to minimize. And we are going to click on the tool here to set the objective. The purpose of clicking on this icon here is to minimize the window for the solver parameters so that we can click exactly on that cell. So I click to move away and I click the cell I want. This is my goal. This is the one we want to minimize. So I've selected and I click to bring the solver tool back up. So I make sure it's minimum. Remember, I selected minimum because we were told we want to minimize the costs. By changing, next step is to change the variable cells. The variable cells are those in which we made our assumptions. So make sure you click in the space where you have changing variable cells, and I'm going to click on the icon to minimize this window again. And I go and select the cells that I made an assumption of. And the dotted line clearly shows you what you have selected. And I'm going to go back and click on that tool to bring this back out. Okay. Next, subject to the constraints. Now we have limitations. Remember, we talked about them. So we are going to add those limitations. So we click add. So I am going to move this out of the way. I hope you pay attention. I may have to minimize. I wanted to just move the screen out of the way. Let's see if I can do that and see whether you can get something. Okay. Almost. Let me just minimize it a bit more. Hold on, let me first cancel this and get this to be reduced. Hold on. I just want to zoom out so that you can see the work. Okay, that's better. So I'm going to go back. The good thing with Solver, even if you're halfway and you close it out, you can still continue with it. So I'm going to go back and click Solver. Remember what we had. We already had our objective, which we set, and it is this one. By changing which cells, we went ahead to select all the assumption cells, and now we want to add. We want to add constraints. Okay, and this is what I wanted to do. I wanted to drag this to the side so that you can clearly see what I'm doing. Now, make sure your cursor is in cell reference. The constraint area has three parts. It has the first part, which is the cell reference, the middle part, where you're going to either select less than, equal to, whether you want an integer, and the third one, which gives the constraint. Sometimes we forget and we don't click in the right spaces, so make sure you're clicking in the right space. So we are going to start with the cell reference. We are going to start with the total that is from each plant. We are going to select the three cells that give the totals from Kampala, Entebbe, and Luwero. There we have that. And we are saying that whatever is sent out from these three, we've selected the cell reference, has to be equal to, because remember we want to optimize, has to be equal to, make sure your cursor is in the constraint, has to be equal to what we can produce from each of those. That is our constraint. Whatever is in this cell, which we put here, has to be equal to what is in these cells over here. So that's one. We are going to add the next constraint. The next one is going to be related to the demand. Again, we are going to go to the cell reference. We are going to select these four. 1, 2, 3, and 4. I've highlighted those cells. All the ones which are showing 666. that is the total that is going to be sent to each of the different districts. And we are saying whatever goes to these districts has to be less than or equal to. Why less than? We may not be able to meet the demand because maybe our plant is not able to supply for everybody. But we are saying has to be less than or equal to. Make sure you click in the constraint. And we are going to go ahead and select our constraint. This is our constraint. And make sure that your selection is also precise. Do not select blank cells, otherwise the computer will get a problem. Okay? And we are going to add. And we have one final constraint. We are going to tell the computer to make sure that what is sent to these different places has to be a full case. We don't want 0.22 or 0.13, 3.2 of a case. We want a full case. It's just like when you're shipping it, maybe a case of soda. You don't ship out one bottle in the case, you ship out complete cases. So we have selected, and the dotted line shows us that we have selected, and we are going to click integer. This tells the computer that we want whatever values are in this space over here to be a full integer. And those are the constraints we have, and we are going to click OK. And when we click OK, it takes us back to where we started out. Okay, so remember we said that the distribution has to be minimum by changing those cells there, and here are the constraints that we have put in. I hope we have put in all our constraints, and you put a tick here to make sure that the computer does not calculate non-negative. Remember we talked about GIGO. If you don't tell the computer to make sure that all these variables are non-negative, it will bring you a minimum cost with negative crates. So make sure you put a tick over there. And we are going to select a solving method. We are going to use simplex LP, that's linear programming, and we are going to click the option solve. We want the computer to solve this for us, because we've put in our constraints, we've put in our requirements. So we click solve, and the computer has come up with something. Sometimes you may click solve and you get a big exclamation mark here saying that solver has failed to find a solution. If that is it, you may need to change your parameters, or you may need to change the constraints that you have put in. So in this case, solver has found a solution for us. We want a report. Okay, so we click answer, and it will give us a report with those answers, and we are going to click OK. And you will notice that the computer has changed what we put in. Remember, we had put in 2222 as our assumption, but look, solver has done this for us. It has gone ahead to change the distribution schedule, and it is making sure that we are maximizing our profit. How do we know? The total from each plant is going to be totally shipped out, and it is showing us from which plant to send each of the different ones. And we know that it is giving us, this is the minimum cost we can spend, or we can give out, given that we are optimizing our distribution. So I hope you've learned from this. You will notice that on the left side, we have the report, and the report shows you the different options or the different criteria that was put in, or the constraints that were put in for us to get the value that we worked with. So this is our sheet 1, and what we were working on this time was using solver. I hope you've learned how to use solver. The important thing is arranging your information properly so that you can quickly select the items, the cell reference you're dealing with, and the constraints that you're dealing with. Okay, see you in the next video. We shall do one more solver, and hope you'll be able to work with solver in your workplace or in class, be able to use it and solve the different problems that are given to you. Good day.